Hi there, and welcome to PF2 Graphing Review. It is, in my world currently, it is Jan, just about school year's out, and I want to finish off this video so I can say that all of Math 30 has a video. So join with me on this fun experience. Okay, so this over here, it's a Cartesian plane. Named after a very famous French philosopher, René Descartes. The guy was most famous for saying, he's pretty famous, but I completely forgot. I think, therefore I am. But the rumor is René was sick. He was laying in bed staring at the ceiling, and he was watching a fly walk around. And somehow he thought, wouldn't it be cool if there was some way that you could track his path? And somehow we came up with this idea of the X and Y, not unlike latitude and longitude that we use on the globe. Anyway, back to work. Label the X and Y axis. X is this one, you know this. Y is this one. This is my plus minus, check. Quadrants. 1, 2, 3, 4, check. Label the origin. Excuse me. You see that? Oh, yeah. Oops. Cool. Coordinates of the origin are 0 and 0. So any points, such as the ones down here, can be described by a set of ordered pairs. Why are they called ordered? What's the point? Because it's always the horizontal number first, then the vertical. Oopsie, try again. Wow. I think when you do directions, it's always latitude and then longitude. And latitude is going this way, and longitude is the long way. Kind of the same. Okay. So it matters. If you get the numbers reversed, then your points aren't in the right spot. Okay, so graph these points. If you need to, although you shouldn't, you can always do that. All right, so this is 4 over and 5 up. So that's A. And minus 2, so it's going to be 2 to the left. Okay, well, I pause the video. Sorry, no, you pause the video. Do the other ones. As I say in almost every video, it's not cool to just watch me. You need to do the practice too. All right, so we got B, now we're on C. So 0, minus 4. And D is minus 3, minus 5. Is minus 5. So notice the difference there, right? I should have put some that were exact first, but order does matter. It's always X first, then Y. And then origin is there. Ta-da. All right. That was easy. Now we have to be able to do the reverse too. So writing the coordinates of points. Oh, bless these people. The letters are all over the place. So I'm going to start up here and see what we get. All right. So I need 2 numbers. My X first is minus 5 and 5. Notice when I write a point, you need the brackets, you need a comma in between. It's always 2 points in there. C is it's -1 and 4. D is equal to negative, so it's -2 and 1. There's J. That's going to be 0 over 1. Up. And H is -1, 0. I'm really regretting not doing these in alphabetical orders. It's starting to make me twitch. Let's go over here. So 4 and 5 do quadrant 1. G over here is 5 up. Sorry, 5 over, 5 up. And H. Now we need E. 1 and 1 down. 1 at -1. And then we're going to go over to A here, which is -1. Oops. -1 and 4. No, that's not right. 1 and negative. Because in this third quadrant, and that's how I caught myself. I know both coordinates are negative. As always, that's my where I screw up often is with negatives. So B is -3 over and -4 down. Graphing hasn't kicked in all the way. All right, a couple other things to remember. The domain refers to all the possible X values that you can have. Now, if we want to translate this specifically, the brackety bits means the set of all X. That bar means such that. So that's the bar. X is an element. That's the funky E of real numbers. Now, if you remember here, I threw in the number system. So real numbers is basically anything that you want. So this means that X can be 2/3 or -3 or 2 or 0 or 6 1/4 or pi or √2. It can be any of those. It's fine. If you talk about it in terms of looking at a graph, it's a graph that's got solid lines on it. There's no holes. It's not just dots. Which brings me to the question that I asked, what is the domain of this graph? And I hope I don't confuse you too much. I have faith, because this should seem familiar from Math 20 when we did the inequalities. So you'll notice here, all of the dots are on corners. So they're all going to be, well, they're not real, sorry, they're not rational numbers. They could be integers. We have negatives, yeah, we got negatives. So if you maybe just look here at this set. We have positives and negatives and zeros, so that makes it integers. Oh, I was overthinking. And now I notice that there's arrows here. Okay, I'm going to give you 2 answers. That way I feel good, and yet it's not getting too weird. you could get away with x such that x is an element of integers, and I'd probably give you full marks. That seems good. If you wanted to get bonus marks, see, because I'm looking at, there's arrows here, so that implies that these go on for ever and ever and ever. So we're good. Or if you really wanted to be fancy, x such that my graph, as low as it goes, is -5, less than or equal to x, which is less than or equal to, how high does my x-axis go? It goes up to 5. So for my list, the highest number I possibly get for x somewhere is 5. And then we still need the x as an element of integers, saying, you know what, we're stuck between -5 and +5, but we're stuck on the integer in between. But I'd probably just be thrilled with that one. All right, the other thing to remember, highlight, domain, range is all the possible y values. And in this function section, it's almost always that. Forget that almost. It's always going to be this when we're talking about domain. In this particular function, range, not so pretty. Sometimes it's YER. Y is an element of real numbers, which means anything will go, but not always. So we have to be careful. But it's going to be similar. So it's the same pattern, except we put y's in instead of the x's. And I can be all fancy. Y such that from -5 is less than or equal to y, which is less than or equal to 5. Y is an element of integers. That would get you some serious bonus marks. Okay, we will see something close to this in our very last chapter when we talk about sinusoidal graphing. But I think that is the end. Yep, that's the end of the page. There's no page 2 to it. So have a lovely day. Thanks for joining.